Welcome to your Finite Math R4 Day 2 lesson. Last time we talked about linear and quadratic equations. This time we're going to talk about rational equations. Our objective is to solve rational equations. That makes sense. So what are rational equations? I am glad that you asked. Rational equations have a variable in the denominator. Because the variable is in the denominator, the solutions to rational equations are restricted. Well, why? A denominator cannot equal 0, or the whole rational expression, the fraction, is undefined. So, before we solve, we restrict our domain of potential solutions by eliminating any values that make any denominator equal to 0. So we're going to restrict our domain from the very beginning, and then at the end, after we have our solution, we're going to make sure that it's not one of those restricted values, one of those values that will make the whole thing undefined. All right, so we're going to solve y over y plus 1 equals 2 over 3. Now, you don't have to worry about denominators like 3 because there's no way we can make 3 equal 0. There's no variable. But y plus 1, we have to have the restriction that y plus 1 can't equal 0. So y cannot equal negative 1. So, we know that. Now we go about solving the problem. Notice we've got one fraction equaling another. We can cross multiply to solve. So I'm going to have 2 times y plus 1 equals y times 3. Alright, so let's do our multiplication. So we're going to have 2y plus 2 equals 3y. Now we're ready to move, gather up our y's. So let's go ahead and subtract 2y from both sides of the equation, and we get 2 equals y. 2 is not equal to negative 1, so it's not going to make a denominator equal to 0, so it is a solution. So yay, y equals 2. Let's go on to b. We've got 12 over a plus 1 equals a. Well, a plus 1 is our only denominator, so we go, okay, a plus 1 can't equal 0, so a cannot equal negative 1. Alright, remember on the last one we cross-multiplied? Well, anytime you've got a fraction equaling something that's not a fraction, just take whatever that something that's not a fraction is and pop it up over 1. Make it a numerator with a denominator of 1. And then you can see to cross multiply. So we're going to have a times a plus 1 equals 12 times 1. All right, I need to distribute that a. So I get a squared plus a equals 12 times 1 is 12. All right, so this is a quadratic because you have a is squared. So remember with quadratics, you want to get everything on one side of the equation and 0 on the other. So we'll subtract the 12 over. Now, remember you have a couple of choices. You can factor and solve if that's possible, or you can use the quadratic formula. In this case, we can factor. So a plus 4 times a minus 3 is going to work. 4 times negative 3 equals negative 12, and 4 plus negative 3 equals that coefficient of a, which is 1. Okay, it equals our b value of 1. All right, so now we set each factor equal to 0. And so we get a plus 4 equals 0, a minus 3 equals 0, and so a equals negative 4, a equals 3. Okay, so let's go on to example 2. We've got 3 over x squared minus 12 equals 0. X squared can't equal 0 because it's in the denominator. So we solve, take the square root of both sides. X can't equal plus or minus square root of 0, so x can't equal 0. All right, let's go ahead and add the 12 to the other side. Yes, I know we've got an x squared, but it's not written in quadratic form yet. We don't have x squared as a factor. It's in the denominator, so we're thinking rational equation right now. So if we add the 12 over here, what can we do? That's right, we can pop it up over 1 and then cross multiply. So we're going to have 3 over x squared equals 12 over 1. So we're going to cross multiply. So we get 12x squared equals 3 times 1, which is just 3. Okay, so we need to divide both sides by 12. So we get x squared equals 3/12. And let's see, we can reduce that, and we'll have x squared equals 1/4. That's great. We need to take the square root of both sides of the equation. Remember, on the side with just the numbers, you do plus or minus. So we do square root of x squared. It's just going to give us x equals plus or minus the square root of 1/4. Square root of 1/4 is a half. So we get x equals plus or minus 1/2. They're not equal to 0, so both of them work as solutions. All right, Let's look at this one. We've got b minus 4 over b minus 2 equals b minus 2 over b plus 2 plus 1 over b minus 2. All right, so we restrict our domain. So b minus 2 can't equal 0, b plus 2 can't equal 0. The third denominator there is b minus 2 can't equal 0, but we've already got that. So b cannot equal positive 2 or negative 2. All right. Now, at first you may think, oh, we've got to get a common denominator to add these two together. And we would, but you know what? We can subtract this over to the left-hand side, and then we'll have both denominators with b minus 2s. And we may be able to put off getting a least common denominator. So let's do that. So I subtract the 1 over b minus 2 from both sides. It cancels here on the right. Over here we have b minus 4 over b minus 2 minus 1 over b minus 2 equals b minus 2 over b plus 2. So now I've got rational expressions with the common denominator, so I can actually go ahead and combine expressions. Remember, we use the common denominator, so b minus 2, and we actually combine the numerators. So b minus 4, and then we have minus, and then 1. Well, b minus 4 minus 1 is b minus 5 over b minus 2 equals b minus 2 over b plus 2. So now we've got one fraction equaling the other. It's time to cross multiply. So we have b minus 2 times b minus 2 equals b minus 5 times b plus 2. So what we have to do now is we need to multiply and then start moving things from one side to the other. So we get b squared minus 2b minus 2b plus 4 equals b squared plus 2b minus 5b minus 10. Oops, we've got some terms that we can combine. We've got some like terms, so let's do that. So we've got b squared minus 4b plus 4 equals b squared minus 3b minus 10. Alright, so let's subtract b squared from both sides, and they'll cancel out. That's really nice. We'll add the 3b to both sides and end up with negative b on the left. And then we're going to subtract 4 from both sides, and that'll give us negative 14 on the right. We just need to divide by negative 1. We get b equals 14, which is not 2 or negative 2, so we don't have to reject that solution. It actually works. All right, last example. We've got 2 over x minus 3 plus 1 over x equals 6 over x squared minus 3x. So x minus 3 cannot equal 0, x can't equal 0. X squared minus 3x factors to be x times x minus 3, so it doesn't really, we've already got x can't equal 0 and x minus 3 can't equal 0, so there's not going to be new problem points that come from that. We know, looking at all of these, that x can't equal 3 and x can't equal 0. All right, this problem is different in that I can't subtract the 1 over x over here and then have common denominator. I can't do the same thing with x minus 3, the 2 over x minus 3. So I'm going to go ahead and get a least common denominator and add these two together. So the least common denominator for these two are x times x minus 3. So that means I need to multiply on top and bottom by x for my first fraction. And then I've got my plus 1 over x, and I need to multiply by x minus 3 over x minus 3 for that second fraction. So that's going to give me 2x over x minus 3 plus 1 times x minus 3 is just x minus 3 over x times x minus 3 equals 6 over x squared minus 3x. So I've got my common denominator, so I'm going to use it, and I'm actually going to combine my numerators. So here's my common denominator, x times x minus 3. Now I'm going to combine my numerators, 2x plus x minus 3. And I just keep recopying this right-hand side, equals 6 over x squared minus 3x. 2x plus x is 3x minus 3. Now, let's go ahead and look at this. X times x minus 3 is x squared minus 3x. And we've got it equaling 6 over x squared minus 3x. This is really cool. Every now and then this is going to happen. If both of your denominators are the same, you can just go ahead and set the numerators equal to each other. It works out just fine, and I'll be glad to show y'all some simpler examples in class to help you understand that. But it's almost like you can just set the two numerators equal to each other, because if the whole fraction is going to be equal and you have equal denominators, then you have to have equal numerators. So we just get to boom, jump down to 3x minus 3 equals 6. Add 3 to both sides and you get 9. Divide by 3, you get x equals 3. And you think, oh great, there's my solution. But then you look back up and check what x can't equal. Oh my goodness, x can't equal 3. So frustrating, but we just found out there's no solution. There's no number that will make a true statement here, because 3 is the only one that might be able to, but when you plug it in, it makes the whole thing undefined. So there just isn't a solution. I know those are the most frustrating problems for students, because it's like, oh my goodness, all that work to find out there's no solution. Well, just think if you were doing some sort of mathematical model of a plant and there was no way to go with this one idea, this one model, without blowing the plant up. If there was no solution to it, you'd want to know. You'd be saving lives. So sometimes, although it's frustrating to find out there's no solution, sometimes it's just a real good thing to find it out. Okay, guys, that's it for your examples. Try the problems to try on your own. Make sure you attempt them all. If you can't get started on one, go back and look and see if there's an example kind of like it, and maybe rewatch the video again. If that still doesn't help you, come on in and I'll be glad to help you with that. But you want to have tried all those problems to try on your own before you get to class. Alright guys, thank you for watching the video and taking good notes. You have a good day. I will see you in class.